Ever wondered what's happening inside your phone or computer? It feels like magic, but it's really science. At the core, computers make choices using tiny yes or no questions, on or off, 1 or 0. This is called binary code, the foundation of all digital technology. Every photo, song, or message is just a long string of ones and zeros to a computer. But how do these ones and zeros become useful? Computers use simple rules to process these signals and make decisions. The building blocks for this are called logic gates. Logic gates are microscopic circuits that control the flow of information. They let computers perform logic, reasoning with ones and zeros. For example, if it's raining and you're outside, you'll get wet. That's logic. Computers do the same, but with binary inputs and outputs. By connecting millions of these tiny decision makers, we build machines that can do complex tasks. It's like building a castle from simple Lego bricks. Every complex action your computer does starts with these basic choices. Understanding logic gates is the first step to understanding AI. Let's see how these gates work. So what are logic gates? Think of them as strict bouncers for electricity. Each gate takes one or more binary inputs and produces a single output based on a rule. The AND gate only outputs 1 if all its inputs are 1, like a bouncer who checks both your invitation and your name. The OR gate is more relaxed. It outputs 1 if at least one input is 1. The NOT gate is a rebel. It flips the input. 1 becomes 0, 0 becomes 1. These three gates, AND, OR, and NOT, are the foundation of all computer logic. By combining them, computers can check conditions, make choices, and control processes. Every app, game, or website relies on these simple rules. Logic gates are the atoms of computation. They're tiny, but together, they make everything possible. With just these three gates, we can build any logical function. They're the reason computers can follow instructions and solve problems. Every digital device you use depends on them. Logic gates turn simple yes, no questions into powerful decisions. They're the unsung heroes of the digital world. Next, let's see how combining gates leads to real decision-making. The magic happens when we connect them. One logic gate alone is simple, but connecting them unlocks real power. Imagine a smart thermostat. It turns on the AC if it's hot in daytime. A temperature sensor and a light sensor each send a signal to an AND gate. Only if both are 1 does the AC turn on. Want more control? Add an OR gate so pressing a manual button also turns on the AC. This is how computers make flexible decisions, by linking gates in clever ways. Circuits that add numbers or store memory are just combinations of these gates. Billions of gates on a chip form the CPU, the computer's brain. Every calculation and instruction is electricity flowing through this network. Simple gates, complex results. So how does this connect to AI? AI is advanced decision-making, recognizing patterns and making predictions. The brain of AI, a neural network, is like a massive web of interconnected logic gates. Each node in the network takes inputs, weighs them, and decides to fire a signal, 1 or 0. For example, an AI learning to spot cats looks at thousands of images. Early nodes detect edges or colors. Deeper nodes combine these to recognize features like whiskers or ears. The AI learns which combinations mean cat by adjusting connections, strengthening the right ones, weakening the wrong. This learning process is just tuning billions of tiny logical decisions. When AI composes music or translates language, it's a symphony of logic gates firing in sequence. The magic of AI is built on the same simple logic as every computer. From simple gates to smart machines, it's all about making the right decisions. That's the power of logic. Today, our world runs on logic gates, from phones to power grids. These tiny circuits are the foundation of every digital device. As AI grows, we need even more powerful and efficient gates. Scientists are pushing the limits, even exploring quantum gates for new possibilities. But the core idea stays the same. Take information, apply a rule, produce a result. Whether in silicon or atoms, logic is the engine of computation. Next time you use AI, remember the trillions of tiny gates working behind the scenes. From simple yes-no to incredible intelligence, it all starts here. The future of AI is bright, thanks to the humble logic gate.